Hey, it's Scott and it's Azure Friday. I'm here with Mark Sims, and we're digging into queues. We did some naive queuing, and then we did some async and some refactoring to make this thing really have some throughput. Can we batch this up somehow and make it even faster?
Absolutely. So queues are limited not in terms of the number of messages you can pull out, but how many times you can go and ask for things. You get a certain number of operations per second. It's like going to a well for water.
Okay.
If I bring a bigger bucket, I'm going to get more on each trip.
Interesting. Okay, so when I talked to Corey Sanders from the VM folks, he talked about that the storage in the disk is limited to like 500 IOPS per second. So you're going to be smart about those. This is the same kind of thing.
Very similar thing, because all the storage works the same under the hood. And it says, I don't care if you put a lot in the bucket or a little in the bucket. You only get so many buckets and so many trips to the well.
Really? So could I have two apps and one does 100 1-byte messages and the other does 101 gig messages? I mean, there's some limit.
Oh, there is, but it's not about the. So in a queue, the maximum size is 8 kilobytes.
I see.
But it's really more how much work do I do in each operation? Do I ask for one message or do I ask for 32 messages, which happens to be the maximum I can ask for.
Well, I'm here.
Yes, fill up my bucket.
That makes sense.
So let's just go and take this app and make a few small changes so that we can get 32 times as much work, theoretically, if there was enough queues, enough messages in the queue, through the system.
So right now we're posting people and we're getting people, and that's kind of what our app does right now.
Get one, give one, or sorry, give one, get one.
Right.
So let's enhance that a little bit. So if we go and we look at how we put messages into the queue, there's nothing we can really do here. If I could set up some in-memory queue that I threw stuff into, like a blocking collection, and periodically pull stuff out of it. Problem is, I can create data loss, because I will have already accepted the message from whoever's publishing to me, put it in memory, and then told you, I've got this. So there's not much we can do about batching on the front end. And that's okay. The real interesting part comes when I want to be able to pull stuff out of the queue in batches and process it more efficiently.
But that makes me worry that you've pulled too much off, you get halfway through the work, and then you die.
Yep.
And the work's only half done.
Well, what you do is if you acknowledge each individual message, it's just I pull 32 and then I execute them concurrently.
Oh, and then if something bad happens, only the ones that have actually succeeded will be marked as deleted. Okay.
Yep. So let's just come down to our worker role. And let's start by coming down to our do stuff. And let's say we don't want to get message async anymore. Let's get messages async. And the maximum we can get is 32, so let's get 32.
Okay. That's
just the magic number. It's just how it is.
And that if there's less than 32, it'll just get them all.
Exactly. Give me up to 32.
Okay.
And what I happen to get back is an IEnumerable of Cloud Queue message. So now, instead of message equal to null, let's actually just change that to messages. So if messages.any.
So any is the enumerable way of saying, is there anything to do here?
This is essentially if count greater than 0.
Right. The link way of doing that.
Yeah. Since this is an IEnumerable we're working against. So then I'll just start again. We'll start naive and then we'll build it up. For each message in messages, we do this. So pretty straightforward. If I get one message, I process one message. If I get 32 messages, I process 32 messages. So far, so good. Couple of small problems. If any of these blow up, well, they're going to take out my whole loop.
Yeah, because there's no error handling on a per message basis.
So let's just drop that in there.
Now you're catching exception, but presumably things that could go wrong, you would check for those specifics.
Oh, absolutely. This is just let's just put a big wrapper around it.
I just want to know what to look for.
I would have more error handling in my process my stuff, but I would always have a, what if I didn't remember something? I would always want to have some form of, not global, but per message handler.
Got it.
Kind of the catch of last resort.
I like that. I'm going to use that now.
Yeah. Well, then there's the catch of last resort.
Right.
This is the catch of last resort.
Are you sure?
Yes.
Yeah, catch, are you sure?
On error, go to next. So that's everything we've needed to do. Now, obviously, we put some real exception handling in a real app, but there we go. We've now basically implemented batch processing.
And how these seemed very small. These concepts seem very small. How would someone know this? Is this Azure specific, or is this cloud specific, or is this just decoupled architecture 101?
This is just brokered messaging in general. Whether you're working with MSMQ, whether you're working with Azure, or whether you're working with Service Bus or Kafka, you have all of these same things. In some of them, they do some of the batching internally in the client. Sometimes the batching isn't as, like an MSMQ, batching doesn't get you very much. It gets you huge benefits in most of the modern brokers.
Is there any reason not to do this? I mean, like for the most part, as we've been building up kind of hello world more and more, why not start out async and batched in 32 right off the bat with pretty much any app?
Up to this point, there's no reason. But there's one small thing we're doing wrong here that we'll dive into, which is I get 32 messages and I process one after the other after the other.
Right.
The last one won't start processing until all the ones in front of it have completed.
True.
So if I need to basically process things with relatively small latency, this will not work for me, especially if one of them in the middle happens to take a really long time.
It'll mess it up for everyone
It'll
else.
mess it up for everyone else. So in general, we might not want to do that. So I might want to get my batch sizes a little smaller.
What about fanning out? Are we on multiple processor machines? Can I go and
let's fan out
parallel for each?
Yeah, let's fan out. We might want to not want to go parallel for each because some of these could have different timings, but we can use tasks. So let's do for each messages. Let's do back to good old task factor.
Right.
And these will not be long-running tasks, so we're not going to do anything special there.
Right.
So let's just take this stuff.
And is that okay? I mean, I don't know how strong or powerful my Azure machine is here. Is it strong enough to go and fire up 32 of these things?
Oh, in general, very much so. Because you're generally going to get, like say, let's take a large machine with 4 cores. You probably have a couple hundred, 100 or so worker threads. Now, if these are all CPU intensive, like rendering jobs, no. Everyone's going to be fighting for the same slice.
I see.
If these are I/O bound activities, like updating storage or a database, this will be fine. But you also need to make sure that those are asynchronous as well, so they're not hogging
So
CPUs.
that the thing, so the process my stuff,
Yeah.
update a database, change a blob. If those are async, then this would be a completely appropriate thing to do.
Yeah.
Very cool.
Yep. And so then the only other thing I do here at the end, let me just make a few little changes, is a new list of tasks. Because we don't want to go back to the well until these are all completed.
I presume a wait all at the end somewhere.
Exactly.
Or is it wait all or when all?
Task.waitAll.
Wait all.
Yep. So we just go and we add that. And a little guy here at the end. All right, so then at the end of the for each, we're just going to do task.waitAll, my tasks.
And that waits for the batch.
Waits for all of them. Well, actually, tasks. This is going to be a little bit complaining because this is a list and this wants an array, so we just...
To array.
Yep. So, because if we didn't put this wait all in, we'd get 32, we'd spawn 32 tasks. We'd get 32 more, we'd spawn 32 more tasks. And very shortly the machine would just die.
And could any one of these, what if one of these took forever? When will it eventually die?
That is absolute, and that's the problem around if you have a bad actor in the system, you will basically be stuck waiting on it. And that would be the next iteration, which is how we basically isolate bad actors using async and basically kill them as they go.
Can we do that next?
We absolutely can.
All right, it's Azure Friday.